Hi students, welcome to my class. Dear students, in the last classes we are discussing the area related to similar triangles and then exercise 2.4. So today we are going to discuss a Pythagoras theorem. So it is a most important, very important theorem. They are asking for 4 marks question or 5 marks questions for this theorem. Okay, be careful. You have to understand properly. See, let us find the prove the Pythagoras theorem. So in a right triangle, square of the hypotenuse is equal to the sum of the squares of the other two sides. In the 7th standard and the 8th standard, we learned the Pythagoras theorem statement. We have to learn it, and then related equations we are learning it. But in this year, we have to discuss the proving of Pythagoras theorem. So let us find proving of Pythagoras theorem. So in a right triangle, so we have to write the first right triangle. Okay, I will draw the one of the right triangle. Okay, this is right triangle at B. So this is ABC is one of the right triangle at B. This is C. Okay, this is the diagram. So given what in right triangle ABC at B, right triangle at B. Now to prove what we have to prove it, that is to prove what is the statement. The right angle triangle, the square of the hypotenuse, we know that already hypotenuse. So what is the hypotenuse? The right angle opposite sides, we call it as hypotenuse. What is the right angle here? Angle B. What is the opposite of angle B? AC. So AC is hypotenuse. What we have to do? Square of the hypotenuse. So first we have to square the hypotenuse. AC is the hypotenuse. If you are doing the square, so it becomes AC square. So square of the hypotenuse is equal to the sum of the squares of the other two sides. What are the other two sides? AB and BC. AB and BC. So sum of the squares of the other two sides. Correct? In a right angle triangle, square of the hypotenuse is equal to the sum of the squares of the other two sides. So this statement we are writing the equations form. So that's why we have to prove it. AC square is equal to AB square plus of BC square. Correct? So shall we go to the next one? So small construction, we have to do small construction. So what is the construction? See, BD is perpendicular to BD is perpendicular to AC. So I will draw the BD line to the perpendicular to AC. Got it? So now proof. Very important proof. So first, see students, first we have to consider, see there are three triangles there. So one is ABD, correct? ABD or ADB, one is the triangle, another BDC is the another triangle. First triangle, second triangle, and then whole triangle ABC. So every triangles it become what? Right angle triangle, because ABC is a right angle at B, ADB is right angle at D, BDC is right angle at D. So the three triangles is also a right triangles. So first we have to consider, this is first triangle, this is second triangle, and then whole triangle. Okay. First I will consider first triangle and the whole triangle. Okay. ABD I will consider first, and ABC and second. So ABD first triangle and then whole triangle you should consider first. So in triangle ABD and triangle, so ABD is one of the triangle and ABC. So I will consider the two triangle, first triangle and the whole triangle. Okay. So what we have to do these two triangles? So first of all we have to prove that these two triangles are similar. Got it? Yes. Come to that. In the similar triangle, what we have to need it? So any two corresponding sides are in the same proportions. or one angles must be equal, then the two triangles are similar, or three sides, corresponding sides are in the same ratio, or any two angles are equal. Okay, shall we find out which is the element we have to find it. See, in that ADB or ABD triangle, angle D is what? 90 degree. Angle ABC in the triangle, angle B is 90 degree. Okay, 90 degree and 90 degree. Got it? So therefore, in the ADB is equal to ABC because of 90 degree. Correct? 90 degree. And then one angle we got it. So another one angle if you have got it means then the two triangles are similar. So another angle C, angle A, because A is common angle. DAB, angle of A is this angles is ADB and ABC. Both angles is the common angle. Angle A is common of ABD and ABC. Okay. Therefore, DAB it is equal to BAC. BAC because of common angle. Okay. Next, therefore, the triangle ABD is similar to triangle ABC by the similarity AA similarity. Okay. Now, when the two triangles are similar, then the corresponding sides are in the same proportion or same ratio. See, I will consider AD by, see here, AD is a side of ABD, correct? This is the base. In that ABC, what is the base? Correct. AB is a base. Got it? So AD by AB. AD is a base of ABD, like that. In that base, we have to take it as a ABC. In the ABC base is AB. Therefore, AD by AB. So that's why I write. It is equal to one side we are writing the proportion. Another side. See, another side. Yes, AB is what? AB is a hypotenuse of ADB. Correct. AC is what? AC is a hypotenuse of ABC. Therefore, AB by AC. Hypotenuse I will take it. AB by AC. Correct? AB by AC. So now we have to do cross multiplication. AB into AB square. It is equal to AD into AC. AD into AC. So call it as number 1. So next, like that, second triangle and the whole triangle we should consider it. So second triangle, in triangle, okay, what is the triangle? BDC and ABC. Triangle ABC. Okay. In that, BDC and ABD, ABC 90 degree. Therefore, BDC it is equal to ABC, it is equal to 90 degree. So one angle we got it. The another one angle, if you have got it, means there's two triangles are similar. So angle C is common. See, BCD or DCB, angle DCB it is equal to angle ACB. Is equal to because of common angle. Okay, common angle. So enough. These two angles, the corresponding two angles are equal. Then the two triangles are what? Similar. Therefore, triangle BDC is similar to triangle ABC because of AA similarity. Okay. Now, when the two triangles are similar, then the corresponding sides are the same ratio or same proportion. See, DC. Yes, DC is the side of BDC. Okay, in like that. ABC, in that ABC, BC is a side. In that ABC, BC is a base. In the BDC, DC is a base. Got it? In that ABC, BC is a base. Therefore, DC by BC. So 1. It is equal to hypotenuse we should take. What is the hypotenuse of BDC? Yes, BC is the hypotenuse. BC by, and then what is the hypotenuse of ABC? Then AC. ABC hypotenuse AC, BDC hypotenuse BC. Okay, BC by AC. So now we should cross multiply that. So BC into BC, BC square, it is equal to BC into AC. BC into AC. Dot is indicated as into. Okay. Next, BC square is equal to DC into AC, called as number 2. So this is 1 and this is 2. Adding 1 and 2. Final step, adding 1 and 2. So what is that one? AB square, or in a said AB square plus of BC square. AB square plus of BC square. It is equal to AD into AC. AD into AC plus DC into AC. DC into AC. In that, AC is a common. Okay. AC here is there. Here also AC is there. So common factor should take out. Remaining AD plus of DC. So AC into, so AD plus DC. You should see in that diagram. AD plus DC. What will you get? AC. Therefore AC. AC into AC. What will happen? AC square. Therefore AB square plus of BC square, it is equal to AC square, or AC square is equal to AB square plus of BC square. Otherwise you should write AC square is equal to AB square plus of BC square. Hence the proof. Understand? It's a very important theorem. They are asking 100%. They are asking in the final examinations. The last year is also asking for 5 marks questions. Okay? So you have to learn properly and practice properly. Okay? That's all. Any doubts? Okay. So next, we will go to the exercise problems. What is the question, exercise? First question. Sides of triangles are given below. Determine which of them are right triangles. In case of right triangle, write the hypotenuse of its, write the length of the hypotenuse. See, they are given the sides. These sides are the right angle triangle sides. We have to check it. If it is the, it becomes these sides are the right angle triangle sides, then we have to calculate the hypotenuse. So let us check it how it is. These sides are right angle triangle or not. So first one, 7 centimeter, 24 centimeter, and 25 centimeter. Correct? Okay. In that, so this is AB, this is BC, and this is AC. So the highest value is an AC. So our format, AC square is equal to AB square plus of BC square. Correct? The highest number is AC. Therefore, I will give the AC. AC square is equal to 25 square. It is equal to AB means 7 square plus of BC means 24 square. So now 25 square means 625. It is equal to 7 square means 49 plus 24 square means 576. Correct? So 625 it is equal to, so 49 plus of 576, 576 plus of 24, 600, 25, 625. So 625 is equal to 625. LHS is equal to RHS. Therefore these are sides of right triangle. Right triangle. Therefore hypotenuse is what? Highest one, 25 centimeter. Understand? So now second one like that, 3 centimeter and then 8 centimeter. What finally 6 centimeter. Okay. In that highest number is 8. Therefore this is AC. This is AB or BC. This is AB or BC. If you are giving AB, this is you should give the BC. Then AC square it is equal to AB square plus of BC square. So now AC square means 8 square, it is equal to AB square means 3 square, BC square means 6 square. So 8 square means 64, 3 square means 9, 6 square means 36. Now 64 it is equal to 36 plus of 9, 45. So 64 is not equal to 45. Therefore, these are not sets of right triangle. Understand? So like that. So question number 3 and 4 are there in the first line. You have to check it in your home. Okay. Shall we go to the second question? Yes. So question number 2. Okay. See here, PQR is a triangle, right angle at P. Okay. I will draw the one of the triangle. Right angle at P. Correct? PQR is a triangle right angle at P. So this is P. P, this is Q, and this is R. Okay. And then PQR is a right triangle at P, and M is the midpoint of QR. This is M. M is a midpoint of QR. Yes, M is a midpoint of QR. This is the right angle. M is a midpoint of QR. Okay. So therefore this one is equal. And then we have to prove that QR such that PM is perpendicular to QR. Okay. PM is perpendicular to QR. PM is perpendicular to QR. Therefore this is perpendicular to each other. PM is perpendicular to QR. Now show that PM square is equal to QM into MR. PM square is equal to QM into MR. We have to prove it. Yes, let me prove it. So first given, what they are given in right triangle PQR at P. Okay, such that PM is perpendicular to QR and M is the midpoint of QR. Therefore, that is QM it is equal to MR. This is given. Now to prove what we have to prove it. Yes, PM square is equal to PM square it is equal to QM into MR. So that this one we want to prove it. So next proof. Student, firstly these two triangles are there here. So first we have to consider first triangles. In triangle PMQ. In triangle PMQ, angle M is a 90 degree. Correct? Angle M is 90 degree. Now PMQ is because PMQ is a right triangles. We are using the Pythagoras theorem. According to Pythagoras theorem, okay, see what is the Pythagoras theorem? So square of the hypotenuse, what is the square hypotenuse here? PQ. So PQ square it is equal to the square of the hypotenuse is equal to square of sum of the squares of the other two sides. Other two sides is PM and QM. PM and QM. So therefore PM square plus of QM square. Now I will take PM square. PM square is equal to PQ square. I will send to the LHS side, so it becomes minus QM square. So therefore PM square is equal to PQ square minus of QM square, equal to number 1. So now I will consider the next in triangle PMR. In triangle PMR, correct? In that angle M is 90 degree. Angle PMR is 90 degree. Correct. Therefore, again, according to Pythagoras Theorem, what is that? PR square, hypotenuse is PR. Therefore, PR square is equal to PM square plus of MR square. Okay. So, I will take the PM square. It is equal to, so MR you have to send here. Therefore, PR square minus of MR square. Call it number 2. Adding 1 and 2. Adding 1 and 2. So PM square, here PM square, 2 times of PM square. It is equal to, here PQ square, here PR square. So PQ square plus of PR square, PQ square plus of PR square, minus 2M square, minus of MR square. Okay, next. PQ plus PQ square plus of PR square. See, PQ square plus of PR square. So call it as, shall we write the QR square? QR square, because PQR is a right angle triangle at P. QR is the hypotenuse. Square of the hypotenuse is equal to square of the sum of the other two sides. Therefore, PQ square plus of PR square, instead of, I will write that this sum, these other two squares of the sum of the other two sides is equal to the squares of the hypotenuse. Therefore, QR square, I will write the QR square. Got it? So next, plus PQ square plus of PR square, I will write the QR square, minus of QM square minus of MR square. Now, QR can be written as QM plus of MR. QM plus of MR whole square. Correct? QR instead of QM plus of MR whole square. Minus of QM square minus of MR square. I will write as it is. Now, this is A plus B whole square format. Correct? I will expand it in the form of A plus B whole square. What is the A plus B whole square? Correct. A square plus of B square plus of 2A. So A is QM square plus of MR square plus 2 times of QM into MR minus of this, you have to write as it is, minus of QM square minus of MR square. Okay. See students, plus QM square minus QM square get cancelled, plus MR square minus MR square get cancelled, remaining 2 QM into MR. So this is what 2 PM square. 2 PM square. Now 2 to get cancelled, remaining what? PM square. It is equal to QM into MR. And support. See, PM square is equal to QM into MR. PM square is equal to QM into MR. Understand? So very simple. You have to practice properly in your home. It will come. Okay. So next question, number 4. Question number third one, as it is there, you have to do in your home. Okay, I will go to the question number 4. So ABC is a isosceles triangle, right angle at C. Prove that AB square is equal to 2 times of AC square. See, ABC is an isosceles triangle. Okay, and also right angle triangle. Isosceles right angle triangle. Okay. See, this one and this one is equal. A, this is B and this is C. Right angle at C. Correct? Yes, right angle at C. Prove that AB square is equal to 2 times of AC square. Basically, isosceles triangles means 2 sides are equal. So, it is a right angle triangle and also a isosceles triangle. Right isosceles triangle. This is. So, AC square is equal to BC. AC is equal to BC here. Correct? So, what we have to prove it? AB square is equal to 2 times of AC square. See, in triangle ABC is a right triangle at C. According to Pythagoras Theorem. So Pythagoras Theorem you have to use it. AB square is equal to, see, AB is a hypotenuse, angle C opposite side AB. It is equal to remaining side AC plus of BC. So AC square plus of BC square. Correct. And AC is equal to BC here. AC is equal to BC because of isosceles time. Now AB square it is equal to AC, I will write as it is right now, plus BC instead of, can I use the AC? BC instead of, I will substitute the AC instead of BC. So AB square it is equal to AC square plus of AC square 2 times of AC square. That's all. Hence the proof. Very simple. 2 more questions. Okay. Next. Like that only, question number 5 is there. Like that only, we have to practice, we have to solve in the form. Okay. So next question number 6, I will go to the question number 6. ABC is an equilateral triangle. Okay. ABC is an equilateral triangle of side 2A. Yes. This is one of the equilateral triangle. In an equilateral triangle, what all sides are equal. Correct? All sides are equal. And then each side is 2A. This is 2A, this is also 2A, and this is also 2A. Now find each of the altitudes in a equilateral triangle. All altitudes are equal, and also in a equilateral triangle, altitude and the medians are same in an equilateral triangle. Correct? Therefore, this is divided in the equal parts. Okay, this is D. So AD is a median and also a altitude. So if it is the consider the median, AD is divided the BC in equal parts. Therefore BC is a 2A. Therefore BD is equal to A and DC is equal to A. Now we have to calculate the AD length. This is the altitude. So in triangle ABC is a equilateral triangle. Okay. In that, therefore AB is equal to BC is equal to CA is equal to 2A, and AD is altitude, that is AD is perpendicular to BC. Okay, this is altitude and also a median. So now AD is altitude, that is AD is a BC, and AD is also a median, that is BD is equal to DC. BD it is equal to DC. Okay. Now I will consider the triangle. In triangle ABD, ABD is a right triangle at D. Okay, because of AD is perpendicular to BC. Now, I will find according to the Pythagoras theorem. So in that, square of the hypotenuse, that means AB square it is equal to AD square plus of BD square. AD square plus of BD square. Okay. Now AB, what is the length of AB? 2A. So this is 2A. So BD is equal to DC. What is the length? A. So 2A whole square it is equal to AD length. We have to calculate AD square as it is right now. Plus of BD length is A. Therefore A square. So now 2A whole square means 4A square. It is equal to AD square plus of A square. A square. So A square you have to send here. 4A square minus of A square. It is equal to AD square. So 4A square times of A square, this is 3A square. It is equal to AD square. So therefore AD square it is equal to 3A square. So AD I want, AD is equal to square root of 3A square. So the square root is apply for 3 and also A square. Square root cancel, remaining root 3A. This is the length of altitude. So therefore AD is equal to root 3A units. Understand, students? It's very simple. you have to draw the diagram properly, and then you have to write the given, what we have to calculate, what we have to find out, that one you have to understand properly, and then you have to find it. Understand? So like this you have to solve it. In the remaining questions we have to discuss in the next class. Okay students, thank you.